What's up, everybody? It's Brett with Prey Performance again. So, to continue to move on with our airflow um, conversation we were having earlier, as I was stating, the engine is just a big vacuum pump. With a naturally aspirated motor, there's no actual forced air coming in. It's all created with vacuum and velocity out the exhaust and some other stuff. You can't create like a ram air deal, which we do. We try and pressurize this. Um, but what I want to talk about is the holistic approach to airflow. So I can slap a head on a flow bench and do this, that, and the other, but at the end of the day, it really doesn't mean anything. A bare head on a flow bench is pretty pointless, to tell you the truth. There's no real validity to the numbers or what it's going to do. What we need to know is how much air is actually getting to that cylinder head, intake and exhaust, with the intake manifold mounted of whatever choice and the exhaust mounted. At that point, we need to manipulate the whole system. We need to reshape our port. We need to reshape our intake manifold. So you can see here I have a MSD, a Holley high ram. A couple of things I'll address on the Holley high ram that are issues that we're working to fix. And also runner length and what that does against runner length of the intake manifold versus runner length and volume of the cylinder head. So as you can see, before we take the lid off, this is a 6.5 inch runner, and it has quite a bit of taper, but all the runners are different. They have different shapes, different forms. So those have to be addressed individually, which takes a little more time. But what I want you to notice is kind of the straight line shot into the cylinder head. It's not completely straight. It's not the angle I would choose. I'm actually developing an intake manifold that will rock that up more and have more taper all the way around. So we're getting a straighter shot at the valve and accelerating the air. The issue at this point that we're having, and we've addressed it and actually picked up 24 rear wheel horsepower with just some small tweaks that I did, is as the air gets pulled in from here, it has to make this sharp 90-degree corner around this narrow entrance here. Once it does that, and bear with me guys, I'm doing this one-handed, and I have two different manifolds to show you guys. So it's got to come over that sharp angle, and then it's got to make it past this, which I address, just to get to the front two cylinders. Now the rest of the cylinders aren't so bad, as the air slopes down and comes into the back. What we've done is we've added a 1 inch spacer on some of them, and then I actually cut this area down with that 1 inch spacer. That's created a lot more cross section and area in there. Like I said, we picked up 24 rear wheel horsepower. Now what this looks like sitting on the engine is like so. I'm going to try and turn it without knocking all of this stuff down. Then I'm going to put a light into the cylinder head. So I don't know if you're going to be able to see it from this angle. This is the intake valve. Let me see if I can. Is that a little better? This would be the intake valve and the cylinder. We need the air to come in from this outside edge and swirl into the port. That swirl causes homogenation with the injection, which is coming in a lot better now with the direct injection system, and that's what helps us get our spark, or excuse me, our better combustion. So I'm going to turn this a little bit. Mind you, this isn't in its final log configuration, let's say. I will do my best. All right, let's get a light. Apologize for the crappy videographer, but I am not a video guy. I'm a fucking head porter. Anyway, if you look down in here, as we look down the cylinder, you can see that, or excuse me, down the intake port, it tapers. But if you notice what we're looking at the light there, you notice we're not seeing the valve. Okay, so that air is actually coming in almost fully to the right side of the valve from our angle. The problem is that's the opposite that we want the air to actually enter the cylinder for the best deal. If you look over here, if we can get a good picture of it, we actually want the air traveling down that side. So it hits that outer wall and it swirls into the combustion chamber. Again, trying to utilize the full circumference of the valve itself. But if you notice, that's a stage 2 port with the stage 2 high ram. We don't have the gasket in here, so obviously it's not lining up perfectly at this moment. But what I wanted to demonstrate was angle. Okay, so as we're going, this thing tapers down. The other thing I want to talk about with this is that you've got the 5 inches of cylinder head runner, plus you've got the 6.5 inches of intake runner. All of that is accelerating the air going at the valve. So when people talk about oversizing ports and my smaller port is so much better and blah, blah, blah. Dude, when I take a holistic approach at this thing, just not buying it. We have a whole lot more going on in a dynamic running motor. The actual cylinder head runner is kind of a minute portion, to tell you the truth. As long as we keep the shaping and the taper still going at the short side, which we have to do some work to slow the air down, because remember, we got to slow air down to make a corner. We got to speed it up everywhere else. So as this taper goes down, we're starting to accelerate the air to help it get around. But we have to slow it down right at the valve. We do that with other little tricks. And again, we're going to try and utilize every ounce of that valve that we can. So I'm going to try and one arm to get this off of here. Sorry. All right, so now if I can get this MSD up there one-armed, let's see. All right, that ain't gonna be the greatest angle in the world. However, if I grab the lid over here, I pop the lid on there as best I can. If you guys notice, the angle of approach with an MSD is completely different into the cylinder head. So, again, we have to consider our ports. We have to look at our ports of how we adjust them in the cylinder head and what we're trying to achieve with the angle in which we approach the cylinder head. So, when it's sitting in this configuration, you can pretty much guess where all the air is going, right? It's not going right at the valve. In this deal, the air is coming in, first of all, coming in here. Now it's got to wrap around this and every other orifice to get in and feed the cylinder. So this is basically an 8.5, 9-inch runner, depending on if you measure the bottom or the top or the center mass of it. Can only do so much with it. So as we come around here and look, rotate this up. Get under here. All right. So, as we can see in here now, see how notice air, remember, wants to go straight? We can't even see the valve. We can't even see a quarter of the intake runner. Even if I get all the way up here as close as I can, we still can't see in there. So that means that the air coming in, remember the lid sits right against this. So you barely have about 1/2 inch of clearance around the runner from the top and the bottom for the air to actually try and get into this cylinder, create a column of air ready to go into the valve, and turn, these drastic angles to get in. So I have to take all that in consideration and figure out how do I accelerate the air, get it to turn corners, and change the angle of approach. Where are my best options to maximize all that other stuff? Now, when I do this stuff, this is how I actually develop my port. I don't just sit there, grind out a port, put it on my flow bench, see how it works. I actually develop the port around the intake manifold and really the throttle body too. That helps me backwards plan how I'm going to get all the air into the cylinder the way that I need it to. So there's a couple other techniques I use. I use my flow bench kind of unorthodox. To be honest with you, I do some odd stuff with it. I'll discuss that in a different video when I put a cylinder head on the actual flow bench. But just as I'm doing this with the intake manifold, this is also how I design my exhaust port. We'll talk more about the exhaust later. However, I will tell you this, that we've tested quite a few companies' exhaust headers on the actual cylinder head on the flow bench, and so far the best we found is a Texas Speed 2-inch. So their design, their collector, all the other stuff, that's given us the best flow numbers so far. So that's why we, basically choose that design. And we've seen the best gains, on an actual functioning running motor. But anyway, I just kind of want to show you guys that stuff. Sorry for the crappy video. I'll try and get a filmographer in here at another date. All right, see you.